Today we're going to be looking at the shape and the bond angles of different molecules. So you've got uh, 5 different types of shapes you need to be familiar with: linear, bent, trigonal, planar, tetrahedral, and pyramidal. So we'll start off with linear. What does that look like? Well, they're arranged in a straight line. So you can see here, if we look at carbon dioxide, these molecules are arranged in a straight line. Okay, so they're linear. Now the reason that they're arranged that way is because these two bonds here, they repel each other. So they're kind of forcing each other away. So they want to be as far away as possible from each other because there's that repulsion forces between the electrons within the bonds. So the way that they can be the furthest away from each other is by being at opposite ends of this carbon, and that creates a linear shape. Now the bond angle for this one is 180 degrees. So the angle between these bonds, this one here, is 180 degrees. So that's linear. Now, if we have a look at the bent arrangement now. So this occurs in water. So you can see here we have H2O, but this time we have a presence of a lone pair of electrons on the top there. So that lone pair, that also repels these bonds here. So it's pushing them down, and these bonds are pushing the electrons back up as well. So they're all kind of pushing away from each other. Imagine you have magnets and you have the same poles. So you have two north poles, you're pushing magnets together, they want to force each other apart. And that creates this kind of bent structure here. Now the angle between this one is 104 to 118 degrees. So that angle can change, but it's around in that range for bent structures. Okay, now trigonal planar. So this is similar to our bent structure, but this time we don't have any lone pair of electrons. Instead, we just have 3 of the same atoms, in this example, bonded to that central boron atom. So because they're all the same, they all repel each other to the same degree. They're all pushing each other away around that boron atom, so they're evenly spaced around it. And that angle is 120 degrees. So all of these will be 120. So that is trigonal planar. Tetrahedral. Tetra means 4. So we have 4 hydrogens bonded around this carbon atom. Okay. And the angle between is 109.5 degrees. So this angle is 109.5 degrees. Now you have to remember that this is in 3D space. So realistically, it's not going to be flat like this. I would encourage you to look up 3D diagrams of, this is methane. Look up a 3D diagram of methane and you'll see just how it sits in 3D space and why that angle is 109.5 and not 90. So if we have a look at pyramidal structures, again, you got to think of it in 3D space. We have this lone pair of electron at the top, and it's pushing down against all of these hydrogen atoms. And these hydrogen atoms are also repelling against each other. There's repulsion forces between all of these different molecules. There's actually higher repulsion forces experienced from the lone pair of electrons. For this lone pair of electrons, it'll actually push down on these bonds more. It'll repel these bonds more than the bonds will repel the lone pair. So that's why it gets this kind of this shape here. Right, and the bond angle between these ones is 107 degrees. Okay. Again, look up 3D images of this is ammonia, and you'll see just how that sits. All right.